Our warm-up for today is we're starting with factoring with special cases, day one. We're going to figure out whether we're using sum or difference of cubes or we're going to be using difference of squares. Here's the three different questions that we're going to do, and we're going to do it on the board over here. So the first thing you got to ask yourself is, can I take out a greatest common factor? If I can take out a greatest common factor, you want to do that first. So when I'm looking at this question right here, I see 27 and 75. I know I can take a 3 out of both of those. And then w to the fifth power and w to the first power, you can take out a single w. That's going to leave me 9 w to the fourth power minus 25. Then you have to ask yourself, are these two terms, are they perfect squares or perfect cubes of each other? When you look at it, 9 is a perfect square, 25 is a perfect square, and so is w to the fourth power. So with this question, I'm going to use the difference, because the subtraction sign right there, the difference of squares. Do not forget about your greatest common factor that you've taken out. That is part of your final answer. So in order to find our values that go into the difference of squares, we are going to take the square root of this one and the square root of this term and figure out what our a and b values are. We know that difference of squares, we have a squared minus b squared. That's going to be equal to a plus b, a minus b for our factors. So we're trying to find our a and b values. If it's squared here, square root both sides, then that gets you your a and b values. So for a, we're going to take the square root of 9w to the fourth power, which is 3w squared. We're going to do the same thing with 25. For our b value, you would take the square root of 25, which is 5. So now that I have my a and b values, I'm going to write those twice, along with the greatest common factor gets brought down. Open your parentheses. We have 3w squared plus 5. And then write it again with the subtraction sign. 3w squared minus 5. If you can go further with the difference of squares, you should. But here, 3 and 5 are not perfect squares. We're going to leave those alone. That is our final answer with a greatest common factor taken out, then using the difference of squares. The next question that we're working with, we're going to do the same thing. We're going to take out a greatest common factor first, if possible, and then we're going to see if we can't do the sum of cubes because there's a plus sign. You don't want to do difference of anything because there's not a subtraction sign right here. So with this question, we have 125, no number in front of CD cubed, so we're going to leave the numbers alone. We're going to look and see what's common between our variables. C to the fourth power, C. No D value over here, no D variable over here, so the only thing I'm taking out is just a single C. C is going to come out as a greatest common factor, which will leave us with 125C to the third power plus D to the third power. Then you ask yourself, I only see a plus sign and a binomial. This is a perfect cube and this is a perfect cube, so I'm going to use the sum of cubes. That equation looks like this. If I have a value that's cubed plus a b value that's cubed, I can find the cube root of that and say a plus b for my values. And then what I do, once I find those values, I'm going to square the a value, put a minus sign, then a times b will go here, plus sign, and I'm going to take my b value and square it. That's what I have to do for this equation to factor it out completely. So we do have a greatest common factor. We're going to underline it. We're going to find our a and b values first because we are using the sum of cubes. We're going to have to say our a value is the cubed root of 125c to the third power, which breaks down to 5c. Our b value is going to be the cube root of d to the third power, which is just d. So now I have to put in my first part. I have my greatest common factor, gets brought down as a c. Open your parentheses, your a value is 5c plus d. Then what you do is we have to fill in the other three blanks by using our a value and squaring it, our b value and squaring it here, and then I take my a and b value, multiply them together, put them here with a minus sign, always. So let's find out what those are. If I have a and I square it, then that is 5c quantity squared, which becomes 25c squared. That goes here. Then I put a minus sign, always. Then I take a and b, and I multiply them together, which is 5c times d, which for us is 5cd. That goes right here. Then the last part is our d value, or is our b value that we have to square. So we have the quantity d squared, which is just, again, d squared. So plus d squared goes here. There's nothing more you can do with factoring. This right here is our answer. Do not get messed up here on the 25c squared and put it just a 5c squared. The square must be carried to the c and the 5 to get 25c squared right there. If you put 5c squared, it is wrong. So let's see what we have to do for the next question. The next question that we have is p to the 6th power q to the 4th power minus q to the 7th power. So we don't have any coefficients, but we do have variables. The common variable between both terms is going to be q to the 4th power. So I'm going to take that out. Going backwards with distributive property, that's going to give me p to the 6th power minus q to the 3rd power. Both of those are perfect cubes. I have a subtraction sign, so I'm going to use the difference of cubes here, which is a cubed minus b cubed. That's the original question. What you're going to do is break it down into a minus b, a squared plus ab plus b squared. That is the formula for that we're going to use for difference of cubes. So now I just need to find my a and b value first. I do have a common factor. That's part of my final answer. So for my a value, I'm going to say the cube root of p to the 6th power becomes p squared. My b value is going to be the cube root of q to the 3rd power, which is just q. So now I'm going to take my greatest common factor, bring it down, q to the 4th. I have my a and b values, so I'm going to say p squared minus q. Everything else is positive in the last factor. So let's figure out what our a squared value is. If we have a squared, we're going to take our a value, which is p squared, and we're going to square that. Law of exponents says that if we have a parenthesis separating our exponents, we multiply them. So that's going to give me p to the 4th power that goes here. Plus sign. Because the formula says it should be a plus sign, that's what you put there. You take a and b, and we multiply them together. It's going to be p squared times q, which is just the same thing again. P squared q. That's going to go right here. And then the last one is our b value squared, which is quantity q squared, the same thing again, q squared plus q squared. If I've done this right on all three of these examples, if I did a 2x3 box here and then I distributed the q to the 4th power, I will get back to my original question. The whole point of factoring is so that we can break each of these polynomials down, and when we get to division, multiplication, add and subtract of rational expressions, we need to be able to do this. That takes care of our warm-up for today.